Hi, I'm Brian LaValle, Marketing Manager for Industrial MOSFETs in the Power Management Devices Business Unit at International Rectifier. In this presentation, I'll be exploring the impact of RoHS requirements on power semiconductor packaging. I will discuss how existing devices conform to the current version of the RoHS directive, but also looking ahead to expected changes in the directive and assessing what that may mean for power semiconductor packaging in the not too distant future. Along the way, I will try to dispel a common myth about what RoHS compliance means in terms of lead content in power packages. This presentation is aimed mainly at engineers who use power semiconductor devices in their designs, but it may also inform those involved in making purchasing decisions, as well as others in design support roles. RoHS, the Restriction of Hazardous Substances Directive Initiative, is an EU law that limits the concentration of lead and other selected substances in electrical and electronic equipment. If a part is designated as RoHS compliant, many engineers will assume that it's completely lead-free. However, in reality, that may not be the case, particularly in the case of a power semiconductor device. The version of the RoHS directive that is currently in effect is known as RoHS 5. This version of the law requires that the semiconductor package be lead-free. However, it provides an exemption for the solder, allowing for the use of lead in the die attach. There is a pending version of the directive known as RoHS 6, which will remove this exemption. However, there are currently some questions about when this exemption for the lead-based die attach will be removed. We'll come back to that issue shortly. But before we do, let's consider the status of the existing power semiconductor packages with respect to RoHS 6. We'll focus specifically on MOSFET packages here. If we look at the smaller surface mount packages, we'll find that these do not contain lead in either the package or the die attach, and so power MOSFETs offered in these packages are typically compliant with RoHS 6. However, if we look at the larger surface mount and through-hole packages in which power MOSFETs are offered, we find that some, like the D-pack, the D2-pack, and the PQFN, do contain lead in the die attach. The two popular through-hole options, the TO220 and the TO247, do not contain lead in the die attach. But if we look at the surface mount package offerings, only the proprietary DirectFET package contains no lead in the package or die attach, and therefore complies with RoHS 6. Hearing about this situation, many engineers have been surprised because the datasheets for power devices in the D-pack, D2-pack, and PQFN frequently specify that the parts are lead-free. Considering this situation, an obvious question arises. Why are some power packages still using high lead content solder to attach the die to the lead frame? The primary reason is that the lead-based solder has a high melting temperature, which becomes important when the customer goes to reflow a surface mount device onto their PC boards. During the customer's manufacturing process, the device is going to be heated up, and it's here that the high melting temperature of the lead-based die attach comes into play, preventing the die inside the package from separating from its lead frame. In contrast, the lead-free die attach has a lower melting temperature, which actually puts the die at risk of detaching from the lead frame. There are some other reasons why MOSFET suppliers stick with a lead-based solder. For example, it provides self-alignment of soldered elements, there's not much manipulation of the die that has to be done when the die is placed onto the solder attach. So ultimately, the lead-based die attach allows for easier MOSFET manufacturing. And there are some other benefits, such as the very low electrical resistance of the solder. Nevertheless, the main reason for lead-based solder in the die attach remains the lack of a robust lead-free alternative because of the melting point issue. Keep in mind this problem is not limited to any particular supplier. It is an industry-wide issue, and the power semiconductor industry is still searching for a solution. For now, there is perhaps only one RoHS 6 compliant alternative to the standard surface mount power MOSFET packages. As noted previously, this is the proprietary Directive package. Instead of using solder die attach, this package uses an epoxy glue as the die attach material. Even the pre-solder balls on the pads themselves are lead-free. So if used with lead-free solder, the Directive is a completely lead-free packaging solution. Now that we have reviewed the status of power MOSFET packages with respect to the RoHS 6 directive, let's consider the near and long-term implications. The exemption for lead-free die attach has been reviewed every 4 years since 2004. Currently, the exemption is due to expire in 2016, which, as of this presentation, is about 2 years away. It is expected that there will be a ruling on whether or not to do away with the exemption in mid-2014. It's not clear whether the exemption will in fact be removed. At International Rectifier, we have informally polled our customers to understand their position on RoHS 6. So far, the consensus seems to be that most customers are not concerned, at least not yet. The one segment of the market that does seem to be concerned about RoHS 6 is the telecom sector, including both the US and European telecom equipment manufacturers. But for the rest of the market, the lack of compliance of standard surface mount power MOSFET packages with RoHS 6 does not seem to be an issue. Perhaps many companies are expecting that the exemption for lead-free solder in the die attach will be extended. At the moment, this is hard to predict, but given the lack of urgency among most of the power semiconductor user base, engineers may take some comfort in the fact that users of traditional surface mount power semiconductor packages, which meet RoHS 5 but not RoHS 6, are sticking with these traditional package options. However, for those who are doing long-term planning, looking 5 or more years down the road, and seeking full RoHS compliance, the RoHS 6 requirements should be on your radar. At the moment, a proprietary package like Directive, which also has a second source, offers one clear path to full compliance with RoHS 6. Most likely, there will be additional RoHS 6 compliance solutions in the future. Consulting with your power MOSFET supplier may give you insight into other package options that could offer a path to RoHS 6 compliance down the road. In the meantime, you may also wish to consult the reference shown here for further background on the RoHS directive. If you have any questions about the materials presented in this video, please email me at blaval1@irf.com. Thank you.